Dear students, I am introducing myself. I am Ajay Kumar, professor in mathematics, having an experience of more than 30 years and worked in various corporate colleges. Now present I am working in RAMABANAM Junior College as a mathematics professor to train the IIT-JEE mains and advanced students. Now today I am going to teach you a topic called trigonometry. So the topic trigonometry you learn from 10th standard because it's a very important topic to connect it to the calculus and coordinate and all the topics. You must learn trigonometry compulsory. That means it will be applied in physics also to solve the more problems like work, power, energy and everything. So trigonometry is the basic knowledge to learn the students and give explanation of the trigonometry. Many one define trigonometry means you are using so many books, you are by-hearting the definition and everything. But without any by-hearting, the definition of the trigonometry is very simple, that to measure sides and angles of a triangle without any geometrical construction is known as trigonometry. Now in trigonometry means what happened, we have 6 friends are there. One was sine, cos, tan, cot, cosec and sec. Because what is sine and what is cos, what is tan and what is cosecant and what is cot. Now I am going to draw the diagram by using the concept that as in a right angle triangle, theta should be any acute angle. Theta is an acute angle, that means less than 90 degrees. I consider this right angle triangle, right angle at B. I called theta as this was an opposite side and this was an adjacent side, and this is nothing but hypotenuse. This is nothing but hypotenuse. Now sin theta is equal to, according to the definition, opposite by hypotenuse. And again cos theta is nothing but adjacent by hypotenuse. And again tan theta is nothing but opposite by adjacent side. We also called as sin theta by cos theta, and cot theta is equal to adjacent side by opposite side. So it is nothing but cos theta by sin theta, and cosecant theta is nothing but hypotenuse by opposite side. So it is nothing but 1 by sin theta, that has a reciprocal of sin theta. And again secant theta is nothing but hypotenuse by adjacent side, and it is nothing but 1 by cos theta is the reciprocal of cos theta. These are called the 6 trigonometric ratios, have the basic knowledge I was given here. The next I will show you the graphs and everything of the sine, cos, tan, cosec, sec and cot. Now, just now I explained sin x, cos x, tan x, cosecant x, secant x and cot x. The graphs are most important. So with graphs you can learn, because I was given the concept of the x-axis and y-axis I was given, and x-axis I was taken degrees or radians I can take, and y-axis I can take the numbers. That as here I am taking x-axis and this y-axis. Here I am taking 0, pi by 2, pi, 3 pi by 2, 2 pi, minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi I was taken. So I was taken the negative side, I was taking the positive side, these angles, and I was given the numbers 0, 1, 2, minus 1, minus 2. We know very well sin 0 degrees is equal to 0, sin 90 degrees is equal to 1. Sin 180 degrees is equal to 0, sin 270 degrees is equal to minus 1, and sin 360 degrees is equal to 0. So what you observed here minus pi by 2, again sin minus theta will be minus sin theta, because sin is an odd function, sin minus x is minus sin x. You know very well the odd function f of minus x is equal to minus f of x. Again sine minus pi, minus sine pi. Minus sine pi is equal to what happened? 0. Sine minus 3 pi by 2, that is nothing but minus sine 3 pi by 2. That is nothing but what happened? It is minus of minus 1 plus 1. So sine minus 2 pi, that is equal to 0. So we observed the everything, the concept. So what we got, the maximum value we got 1 and the minimum value we got minus 1. So what is the range of sin x which lies in between the closed interval of minus 1 comma 1. So it is a continuous curve because sin x is a continuous curve, it passes through origin. This is a graphically representation of sin x. Similarly, when I am teaching the cos x graph, again cos 0 is equal to 1, cos 90 will be 0, cos 180 will be minus 1 and cos 270 will be 0 and cos 360 will be what happened? 1. Again cos minus pi by 2, cos is an even function, cos minus x is equal to plus cos x. You know very well the even function f of minus x is equal to plus f of x, therefore the function is said to be even function. Now cos minus pi by 2, we can write cos pi by 2, that is 0. Again cos minus pi is cos pi is equal to what happened? Minus 1. Cos minus 3 pi by 2, that is nothing but cos 3 pi by 2, the value will be 0. And again cos minus 2 pi is nothing but cos 2 pi, again the value is equal to 1. So what we observed here, the maximum value of cos function is 1 and the minimum value of the cos function is minus 1. So the range of the cos x is nothing but in the closed interval of minus 1 comma 1. So and we observe this graph is a continuous curve because therefore sin x and cos x both are continuous curves, but it does not pass through the origin, whereas the sin x passes through the origin. And similarly we can go for tan x, we can go for cot x, because the tan and cot are both are reciprocal functions. So we observe that tan 0 is equal to 0, tan 30 is equal to 1 by root 3, tan 45 that is equal to 1, again tan 60 root 3, tan 90 is not defined. Why it was not defined means what happened? We know very well the domain of tan x. The domain of the tan x means what happened? X belongs to R except odd multiples of 90 degrees. So we cannot define tan 90, so we cannot define tan 270, so we cannot define 450 degrees, we cannot define 630 degrees. So we can write that x belongs to R where x belongs to R except odd multiples of 90 degrees. That's why it is a discontinuous at 90, we observed that. Again it is a discontinuous at 270 degrees, again it's a discontinuous at minus 90 degrees, again it's a discontinuous at minus 3 pi by 2, that is nothing but minus 270 degrees. This is the graph of tan x. And what is the range of tan x? That means range of the tan x is nothing but minus infinity to plus infinity open interval, because we cannot take it should be the closed interval because it is not equal to infinity and not equal to minus infinity. Therefore the tan x value which lies in between minus infinity to plus infinity in the open interval. Similarly I can give the cot 0 means 1 by tan 0 not defined. Again cot 90 will be what happened? 1 by tan 90. Tan 90 was not defined, 1 by not defined was 0. So again pi, we got the value 3 pi by 2, again 2 pi, the intervals you are going to take the value of x and same thing. So cot x is also a discontinuous curve, discontinuous at the integral multiples of pi. That means we are not defining at x is equal to 0 degrees, we are not defining at x is equal to 180 degrees, we are not defining at x is equal to 2 pi degrees. Similarly, we are not defining at x is equal to minus pi, we are not defining at x is equal to minus 2 pi. Therefore, cot x is a discontinuous curve, discontinuous at the integral multiples of pi, and x belongs to R except n pi. If n is 0, we are not defining at 0. If n is equal to 1, we are not defining at 180. When n is equal to 2, we are not defining at 2 pi, like that. So now similarly I can go for the graphs of the cosecant x and secant x. Next, the cosecant x value always greater than or equal to 1 or less than or equal to minus 1. The value of the cosecant x, that is greater than or equal to 1 means 1 to infinity, and less than or equal to minus 1 means minus infinity to minus 1 closed. So I was given in the graphs very clearly. So minus 1, here 1, again it is minus 1, it is 1, and the value you observe that it is greater than or equal to 1 or less than or equal to minus 1. The value does not lie in between minus 1 and 1. The value does not lie in between minus 1 and 1. And you know very well the domain of the cosecant x, like you know very well 1 plus cot square x is equal to cosecant square x. When LHS is equal to RHS, if and only if they have the same domain. Already I discussed about the cot x, because cot x means x belongs to R except n pi. Same thing, because we are using an identity 1 plus cot square x is equal to cosecant square x. The cosecant x, the domain of the cosecant x is nothing but x belongs to R except n pi and n belongs to z. So similarly I can, and these cot x and cosecant x and tan x, the three are also discontinuous. Now I can discuss secant x. We observe that like cosecant x, the secant x value which is greater than or equal to 1 and less than or equal to minus 1. The value of secant x does not lie in between minus 1 and 1, which is greater than or equal to 1 or less than or equal to minus 1, and a minus infinity to minus 1 closed union of 1 comma infinity, we learned this one. So this is the concept of the graphs. If you know very well the graphs, then the trigonometric, all the trigonometric functions, you can find it very easily. Okay, you can find it very easily. Now I can discuss the explanation of identities. So explanation of the identities means we have three identities will be there. One is sin square theta plus cos square theta is equal to 1. Suppose an objective question they can ask here, a 10th standard student, they are teaching the proofs and everything, opposite by hypotenuse whole square, adjacent by hypotenuse whole square, and opposite square plus adjacent square is nothing but hypotenuse square by hypotenuse square is equal to 1. So it is not like that, because in higher classes, when you are entering into the higher classes, you should be know the domain, because I already told by using the graphs, sin square theta plus cos square theta is equal to 1. Sin and cos both are continuous curves. Therefore, I can give the domain is theta belongs to R. That means what happened? When LHS must be equal to RHS, they should have the common domain. Otherwise, LHS is not equal to RHS. Okay, next I am going for 1 plus tan square theta. 1 plus tan square theta is equal to secant square theta, because the tan and secant both are discontinuous curves. Discontinuous at the odd multiples of pi by 2. So I can give odd multiples of pi by 2 means what happened? Theta belongs to R x except odd multiple means I am going to take 2n plus 1 into pi by 2 and n belongs to z. This is the concept we learned. When LHS must be equal to RHS, they should have the common domain. So 1 plus tan square theta is equal to secant square theta. The next I am going to the third concept, 1 plus cot square theta is equal to cosecant square theta. So the cot and cosecant both are the same concept, both are discontinuous curves. So cot and cosecant discontinuous at the integral multiples of pi. So I can write it should be in the form of theta belongs to R except n pi when n belongs to what? Z. So these are the identities. In below 10th standard, the teachers won't teach all the things, But in intermediate +1 and +2 students, you should learn the common domain that has what I was given the three concepts. So sin square theta plus cos square theta is equal to 1. We can write cos square theta is equal to 1 minus sin square theta. Again, sin square theta can be taken as 1 minus cos square theta. They should have the common domain, theta belongs to R. Now, 1 plus tan square theta is equal to secant square theta, and secant square theta minus tan square theta is equal to 1. Again, secant square theta minus 1 is equal to tan square theta. Again, 1 is equal to secant square theta minus tan square theta, and both will be, when LHS is equal to RHS, they should have the common domain. If I give theta 90 degrees, tan 90 was not defined. If I give theta is equal to 270 degrees, tan 270 is not defined. Similarly, if I give theta is equal to 90 degrees, secant 90 was not defined. If I give theta is equal to 270 degrees, secant 270 is not defined. So, overall explanation I am going to give that theta belongs to R except the odd multiples of 90 degrees. Similarly, I am coming to the third one. 1 plus cot square theta is equal to cosecant square theta. They should have the common domain. If I give theta 0 degrees, cot 0 is not defined. If I give theta is equal to 0 degrees, cosecant 0 is not defined. If I give theta 180 degrees, cosecant 180 degrees, now theta is not defined. So, cot theta is not defined, cosecant theta is not defined at 0 degrees, at 180 degrees, at 360 degrees, at 540 degrees, like going on. So, I am writing the now general value, theta belongs to R except n pi, n belongs to Z. This is the three identities are important to solve the questions, the topic of identities and ratios. Now, known values of trigonometry. Known values of trigonometry. Known values of trigonometry. Students, you know very well the known values. That one, up to 10th standard, you learn the values. You are by-hearting the values. But now what happened? Mathematics with the love you can develop. So, mugging is not compulsory, just concentration is most important. How to find the values? Small trick I am playing here. 0 degrees, 30 degrees, 45 degrees, and I am taking 60 degrees, 90 degrees. Because you don't by heart a table wise. You should learn very simple method that I am giving that sign. I am giving that 0, 1, 2, 3, 4 divided by 2. This is a very simple concept. You can learn very simple. Now, sin 0, root 0 by 2, 0. Sin 30 degrees, root 1 by 2, 1 by 2. Sin 45 degrees, root 2 by 2, 1 by root 2. Sin 60, root 3 by 2. Sin 90, root 4 by 2, but root 4 is equal to 2, so 2 by 2 is equal to 1. It's a very simple concept. Now, sin 0 degrees, we can write 0 by 2, 0. Again, sin 30 degrees, it is root 1 by 2, that is 1 by 2. Again, sin 45, I am writing here root 2 by 2, that is nothing but 1 by root 2. Again, sin 60 degrees is nothing but root 3 by 2. Again, sin 90 is nothing but root 4 by 2. That is, root 4 is nothing but 2. So, 2 by 2 is equal to 1. This is a simple logic because you don't by heart all the formulas and everything. What I use, sin I am using 0, 1, 2, 3, 4 by 2. Simple method. Now, cos I am using, it should be there 4, 3, 2, 1, 0. 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. So, by 2. So, what we observed that cos 0, root 4 by 2, 2 by 2, 1. Again cos 30 degrees, root 3 by 2. Again cos 45 degrees, root 2 by 2, 1 by root 2. Again cos 60, root 1 by 2, that is 1 by 2. And cos 90, root 0 by 2, that is 0. So we can write very simple logic. Cos 0 is root 4 by 2, that is 2 by 2, 1. So this is a decreasing order, 4, 3, 2, 1, 0. Sine is an increasing order, 0, 1, 2, 3, 4. Now again that has a cos 30 degrees, I can write this as root 3 by 2. Again cos 45, I can write as root 2 by 2, that I can write as 1 by root 2. Again cos 60, I can write as root 1 by 2, that is 1 by 2. And cos 90 is equal to root 0 by 2. Root 0 by 2 is nothing but 0. These are the values. Simply by trickily we can tell that. So you don't by heart the values of known values of trigonometry, because every student has to learn these values without any mugging, Now the topic what we learned in the graphs and everything, I am going to design now function, domain and range. Now I am writing as function, domain and range. It should be most important. Now function, I am teaching only the 6 trigonometric ratios only. Other trigonometry, the later we can discuss. This is because it is based on identities and ratios. So the function I am taking sin x function. Sin x means sin x and cos x both are continuous curves. Therefore the domain is x belongs to R. Cos x also x belongs to R, because both are continuous curves. So the domain will be same. And range, minimum value -1, maximum value is equal to 1. What we observed in the graphs I showed, that as the minimum value is -1, the maximum value is equal to 1, which lies in between the closed interval of -1, 1. Whereas the cos x, closed interval of -1, 1, that means what happened, the minimum is -1 and maximum is 1. The value of cos x and sin x, which lie in between the closed interval of -1, 1. And third one was tan x. I am writing very simple logically, tan x, and again I am taking as secant x. Why I am taking like that? Because 1 plus tan square x is equal to secant square x. Should have the same domain. That means because the tan 90 is not defined, tan 270 is not defined, tan 450 is not defined. Similarly, secant 90 was not defined, secant 270 was not defined, and secant 450 degrees also not defined. So I am writing the domain as x belongs to R except odd multiples of 90 degrees. Now same thing, x belongs to R except odd multiples of 90 degrees, because the identity they should be have the common domain, Tan x range -infinity, +infinity. The value of secant x, I told that as a greater than or equal to 1 or less than or equal to -1, the value does not lie in between -1 and 1. So we are writing this as -infinity to -1 closed and union of 1, infinity. And fifth, I am taking cot x, and sixth I am taking cosecant x, because already I explained in the identities 1 plus cot square x is equal to cosecant square x. Now cot x and cosecant x have the same domain. That means if I give x is equal to 0 degrees, cot 0 is not defined, cot 180 was not defined, cot 360 degrees was not defined. Similarly, cosecant 0 is not defined because 1 by sine 0. and cosecant 180 was not defined and cosecant 360 was not defined, they should have the common domain. That means x belongs to R except n pi and n belongs to z. And here also cosecant x belongs to R except n pi, n belongs to z. Again cot x, the range of tan x and cot x will be same, that as minus infinity to plus infinity in open interval, because it is not equal to infinity, it is not equal to minus infinity, the value which lie in between minus infinity to plus infinity. Similarly, cosecant x and secant x range will be same, because I showed in the graphs the cosecant x and secant x. That means what happened, the value of the cosecant x is greater than or equal to 1 or less than or equal to minus 1. The value does not lie in between minus 1 to 1. So, I can write this as minus infinity to minus 1 and union of 1 comma infinity. This is the concept of 6 trigonometric ratios: function, domain and range. You should learn all the things by using, without any mugging, all the things. With a tricky approach, you can do it all the things. Now, allied angles property. After identities and ratios, the function, domain and range, the allied angle is also most important. The allied angle means what happened? The properties of the allied angle. That means I am easily concept of allied angle addition and subtraction. 90 plus theta, 90 minus theta, again 270 minus theta, 270 plus theta, and again I am teaching 180 minus theta, again 180 plus theta, again 360 minus theta, again 360 plus theta. This is the allied angles we should learn, because I want 150 degrees value. I can take 90 plus 60 because you know the known values 0, 30, 45, 60 and 90. By using that angle, I want 150, I can take. Theta will be 30 degrees, 180 minus 30 I can take. I want 150, 90 plus 60 also I can take. So, I am simple technique I am using that. Just add sugar to coffee. Add sugar to coffee. So, previously your teachers will teach that all silver tea cups, but I am teaching that add sugar to coffee. In the first quadrant, all 6 trigonometric ratios are positive. In the second quadrant, 90 to 180, yes means sign positive. Sign का reciprocal कौन है? Cosecant positive. Now third quadrant, tan का reciprocal कौन है? Cot is positive. And fourth, cos, because the 270 to 360 degrees, cos का reciprocal कौन है? Secant. So secant is positive. So cos secant is positive in the fourth quadrant. In the first quadrant, all 6 trigonometric ratios are positive. In the second quadrant, sin and cosecant x is positive because which lies 90 to 180. Here third quadrant, tan and cot are positive because which lies in the angle 180 to 270. This is a concept. Now I am teaching, just you observe that very easy concept, don't mug. 90 minus theta, 90 plus theta, again 270 minus theta, again 270 plus theta, very simple concept. So first I am writing sin 90 minus theta, cos 90 minus theta, again tan 90 minus theta, just 3 I am taking because you know very well, if I teach sin, cos, tan, you can learn cosecant, you can learn secant, you can learn cot. So 90 allied angle means 90 plus or 90 minus. Sin 90 minus theta, cos 90 minus theta, tan 90 minus theta. First of all, you write like that. Whenever 90 and 270 allied angles are given, you will get the friendly ratio. And plus or minus depends upon the quadrant system. So, sin का friend कौन है? Cos. Cos का friend कौन है? Sin. And tan का friend कौन है? Cot. So, sin का दोस्त cos, cos का दोस्त sin, tan का दोस्त cot. Now, 90 minus, where it lies? It lies in first quadrant. Because 0 to 90 degrees. So 90 minus means less than 90 degrees. A means all trigonometric ratios are positive. Now sin will be positive, cos will be positive, and tan will be positive. This is the concept. To learn very easily the concept. Similarly, I can write sin 90 plus theta, again cos 90 plus theta, again tan 90 plus theta is equal to I am writing. What I told, 90 and 270 allied angle, we will get the friendly ratio, and plus or minus will depends upon the quadrant system. First sin का दोस्त cos, cos का दोस्त sin, tan का दोस्त cot, but 90 plus where it lies? It lies in second quadrant. In second quadrant, who is positive? Sin is positive. Cos is negative, tan is negative. So you can easily find out. Now 270 also you can find out. So 90 and 270 allied angle, we will get the friendly ratio, and plus or minus will be changes according to quadrant system. Similarly, 180 and 360 degrees allied angles, 180 and 360 degrees allied angle, we will get the same ratio. Sin means sin, cos means cos, tan means tan. Again plus or minus changes according to quadrant system. You don't mug these all the things. By remembering the concept and everything, you can find out the values like 150, 210. You can find 210. 210 can be taken as 270 minus 60 or 180 plus 30. We can find out the angles very simple way, very tricky way we can apply it. So again, once 90 and 270 allied angle, we will get the friendly ratio, and plus or minus will be changes according to the quadrant system. Now 180 and 360 allied angles, we will get the same ratio. Sin means sin, cos means cos, tan means tan, cot, cosec, secant. But plus or minus will be changes according to the quadrant system. Now, to find the values of sin 15 degrees, cos 15 degrees, tan 15 degrees, sin 75 degrees, cos 75 degrees, tan 75 by using the compound angle. By using the compound angle means I can use that as now we are using the formula sin of a plus b. Now sin of a plus b is nothing but what happens? Sin a cos b plus cos a sin b. Now this is a formula, is important, is called the compound angle. Addition or subtraction of more than one angle. More than one angle means two angles, three angles, whatever the angle. We called it should be the compound angles. Now by using the simple technique, I am finding that now I want to find 75. I want sine 75 degrees. I can write it as 45 plus 30 I can write. Because you know 45 degrees angle, you know 30 degrees angle. Sin A plus B, that is sin A cos B plus cos A and sin B. You know very well sin 45 degrees value, you know 1 by root 2, cos 30 is nothing but root 3 by 2, cos 45 is nothing but 1 by root 2 and sin 30 is nothing but 1 by 2. So, what is the LCM we are going to take? 2 root 2, root 3 plus 1 by 2 root 2. So, sin 75 value is what? Root 3 plus 1 by 2 root 2. But I can write sin 75 also can be written as sin 90 minus 15. Sin 90 minus 15 degrees is equal to cos 15 degrees. So, cos 15 degree value is also equal to root 3 plus 1 by 2 root 2. So, by using only one formula, I am finding two values. One is sin 75 and one is cos 15 degrees. Similarly, I am giving another formula, that is sin of A minus B. Sin of A minus B is equal to sin A cos B minus cos A sin B. Now, I am taking, you know very well, the sin 15 degrees I want to find. So, sin 45 minus 30 or 60 minus 45, whatever you can take. So, I am taking 60 minus 45. Now, sin 60 into cos 45 minus cos 60 into sin 45. Now, this is nothing but sin 60 is nothing but root 3 by 2, cos 45 is 1 by root 2, again cos 60 is 1 by 2, sin 45 is 1 by root 2. So, it is nothing but root 3 minus 1 by 2 root 2, sin 15 is nothing but cos 75. So, we can find very simply. So, 15 can be taken as 90 minus 75, sin 90 minus theta is equal to cos theta. So, we can find the values, the remaining. So, already 4 values I can find. Sin 15 we got, sin 15 is equal to root 3 minus 1 by 2 root 2 is equal to cos 75. Again, sin 75 is equal to root 3 plus 1 by 2 root 2 is nothing but what happened? Cos 15 degrees. So, similarly, tan 15 is nothing but sin 15 degrees by cos 15 degrees. Again, tan 75 is nothing but sin 75 degrees by cos 75 degrees. We can find by using the tan theta concept, sin theta by cos theta. Now, relation between multiple and submultiple angles. A relation between multiple submultiple angle. So, multiple angle means A, 2A, 3A, 4A, you multiply some number. Submultiple angle means division, A by 2, A by 4, A by 8, these all the called the submultiple angles. Now, we are connecting multiple and submultiple, the relation between the multiple and submultiple. So, you know very well sin 2A, because before concept I was given sin A plus B. Sin A plus B formula is what? Sin A cos B plus cos A sin B. In the place of A, I am taking now A plus B. In the place of B, again I am taking A plus A is equal to 2A. Sin 2A is nothing but 2 sin A cos A. That because sin A plus B formula is nothing but sin A cos B plus cos A sin B. Replacing in the place of B A, so sin of A plus A and sin A cos A plus cos A sin A. is nothing but 2 sin A cos A. Now this is the relation between the multiple and submultiple angle. So your multiple is 2, you are getting half. If it is 4 sin 4A, so what will write? You can write 2 sin 2A cos 2A. So this is called the relation between multiple and submultiple. Now we can write sin 6A. What will write? 2 sin 3A cos 3A. Like we can write anything. Similarly, we can write so many things. And cos 2A, we know very well cos A plus B formula. Cos A plus B is equal to cos A cos B minus sin A sin B. Again I am replacing B as A, so I am taking A plus A. So cos 2A, that is nothing but cos A into cos A minus sin A into sin A. Now it is nothing but cos square A minus sin square A. Now we can write this as cos square A can be taken as 1 minus sin square A. So 1 minus 2 sin square A. Again I am writing sin square A can be taken as 1 minus cos square A. So 2 cos square A minus 1. So what we observed that if multiple is 2, now submultiple you are getting A. If multiple is equal to 4, submultiple you are getting 2A. Similarly, I am writing that cos 4A is equal to 2 cos square 2A minus 1. So that is called the relation between the multiple and submultiple angles. That means again cos 6A, 2 cos square 3A minus 1. So that is the relation between the multiple and submultiple angle, and we can write in terms of tan also. Sin 2A can be taken as 2 tan A by 1 plus tan square A, and cos 2A can be taken as 1 minus tan square A by 1 plus tan square A. So later we will discuss about tan A plus B, tan A minus B, tan 2A, cot 2A, cot A plus B, cot A minus B. We can learn very detailed explanation.